When your car's AC suddenly starts blowing hot air instead of ice cold, here's the real question. Is this a $50 fix or a $3,000 disaster? The overwhelming majority of cars blowing hot air have nothing wrong with expensive components like compressors or condensers. Instead, they're suffering from easily diagnosed issues that cost almost nothing to fix when you understand the systematic approach that professional mechanics use. Over the next few minutes, I'll walk you through 10 secrets that will make your hot car AC blow ice cold again. I'm also going to reveal 2 critical mistakes that 90% of vehicle owners make. These mistakes can lead to air conditioning or engine damage that can cost up to $3,000 to repair. Secret number 10 is checking your blend door actuator first, because this single component controls whether hot or cold air reaches your cabin. Yet 90% of repair shops will try selling you a $1,500 compressor instead of diagnosing this $50 fix. Locate the blend door actuator under your dashboard on the passenger side. This component positions a door that mixes hot air from your heater core with cold air from your evaporator. When the plastic parts break, which happens frequently in Chevrolet vehicles like the Tahoe, Avalanche, and Traverse, you'll only get hot air because the door stays stuck in heating position. Test your blend door actuator by having someone adjust your temperature dial while you watch the mechanism. If the gears don't move smoothly or remain frozen, that's your problem. Fix this by removing your car HVAC system fuse for 2 minutes to recalibrate the activator. If that temporarily restores cold air, you need actuator replacement, not expensive AC service. This simple test can save you over $1,000 in unnecessary repairs. Secret number 9 helps you avoid the $1,200 compressor replacement scam that happens when mechanics see your compressor pulley spinning and assume everything works properly. Listen for the audible click when you turn on your air conditioning. That's your compressor clutch engaging. You hear that click and see the center hub spinning with the outer pulley, your compressor is actually working. The pulley spins constantly with your engine, but refrigerant only gets compressed when that electromagnetic clutch connects the center hub. Take the case of a 2007 Ford F-150 with a 5.4-liter engine that came in blowing hot air with grinding and whining noise near the serpentine belt and pulleys. The AC gauge was reading very high pressure, over 100 pounds per square inch, in the red zone. While grinding noise suggests mechanical failure, high-pressure readings alone don't definitively indicate compressor failure without additional diagnostic confirmation. If the clutch center stays motionless while the outer pulley spins, your compressor cannot pump refrigerant no matter how much Freon you add to the system. Test for electrical problems before replacing expensive AC compressor. Blown fuses, failed relays, or bad wiring prevent compressor clutch engagement and create symptoms identical to mechanical failure. Honda vehicles particularly suffer from air conditioning clutch relay failures. You can swap your air conditioning relay with your horn relay to test this instantly. If swapping relays restores cold air, you've saved yourself a $1,000 repair with a $15 part. Measure voltage at your AC compressor connector when the clutch fails to engage. Some vehicles allow compressor clutch air gap adjustment using shim washers that can restore proper engagement without full compressor replacement. But if voltage is missing, trace your electrical problem through fuses, relays, and wiring before condemning mechanical components. Secret number 8 exposes the low refrigerant trick that costs thousands in unnecessary repairs, while teaching you how to read refrigerant pressure gauges so shops can't fool you. Here's the truth about refrigerant. It operates in a completely sealed system and never just disappears on its own. If your AC is low on Freon, you have a leak somewhere that must be fixed before adding more refrigerant does anything permanent. When your AC works at first but stops cooling after 10 to 20 minutes, or blows cold while driving but hot when idling, you're dealing with a refrigerant leak, not a dead compressor. Consider the 2012 Audi A4 case, where air conditioning pressure gauges showed very high pressure initially, over 100 pounds per square inch in the red zone. After releasing pressure to 35 to 45 pounds per square inch, the air conditioning still blew warm air, with compressor clutch appearing to engage normally. This demonstrates that high pressure combined with warm air output indicates component failure rather than simply incorrect refrigerant charge. Pressure readings alone don't determine proper diagnosis when underlying component failures require different repair approaches. Stop using DIY refrigerant refill kits because these cans cause more harm than good, turning $50 problems into $1,500 system replacements. Over-the-counter recharge cans with sealants damage your air conditioning system instead of fixing underlying problems. Always check both low and high pressure sides with gauges before adding any refrigerant. Professional diagnosis requires special equipment that measures actual refrigerant amounts, pressures, and system oil levels, rather than relying on simple pressure gauge readings that can be misleading without considering ambient temperature and operating conditions. Here's what different pressure readings mean. If both sides show almost the same pressure while running, either your compressor is dead or expansion valve failed. If low pressure side is too low and high pressure side is too high, your system is low on refrigerant or has a blockage. If both sides are way too high, you have too much refrigerant or bad airflow through the condenser. Charge your system by weight rather than pressure readings, because pressure measurements alone don't guarantee correct refrigerant charge. Overcharging damages compressor valves and creates symptoms similar to other AC problems, including intermittent cooling and cycling between hot and cold air output. Very hot ambient temperatures like 120 degrees Fahrenheit can stress the system and make cooling less efficient. But the AC system should still produce noticeably cool air under normal circumstances. Small refrigerant leaks need ultraviolet dye injection followed by UV light inspection to find exactly where refrigerant escapes. The 2010 Mazda 3 case demonstrates this perfectly. The air conditioning was recharged but started blowing hot air again within 2 weeks. Despite system evacuation and dye testing to find leaks before recharging, no leaks were detected, yet the system failed shortly after recharge. This shows that significant leaks exist somewhere in the system, despite testing, indicating limitations of standard leak detection methods for small or intermittent leaks. Electronic leak detectors often miss these small leaks completely. Recharge with exact manufacturer-specified refrigerant amounts, including appropriate compressor oil and leak detection dye, after proper system evacuation and leak repair. Secret number 7 helps you spot when your AC condenser fan dies, and this sneaky problem acts just like other expensive car issues. Your condenser works like a heat exchanger. It takes scorching hot refrigerant and cools it down using outside air. The fans are crucial because they force air across the condenser coils to steal that heat away from the refrigerant, turning it back into cold liquid ready to cool your cabin. Here's the telltale sign. Your car's AC pumps out freezing cold air when you're cruising down the highway, but the moment you stop at a traffic light or park in your driveway, it starts pumping hot air instead. This classic symptom means your condenser fans are either completely dead or spinning way too slow to pull heat away from your AC system. Test your condenser fans by cranking your AC to maximum cold and open your hood while the engine idles. Listen closely. You should hear both the condenser fan and radiator fan spinning when your AC runs. These fans push fresh air through the condenser fins, which your system desperately needs. If one fan quits working, your refrigerant gets stuck holding onto heat, making your AC blow warmer air and possibly damaging expensive parts. Replace failed condenser fan motors instead of expensive air conditioning components when you've confirmed fan failure. Clean your condenser coils simultaneously because blocked airflow creates similar symptoms and puts additional strain on functioning condenser fans. This repair typically costs under $200 compared to thousands for unnecessary compressor or refrigerant system service. Secret number 6 exposes the engine cooling system connection that nobody mentions but directly affects air conditioning performance in ways that cost you hundreds in misdiagnosed repairs. Check your engine thermostat first when air conditioning problems coincide with engine temperature issues, because a malfunctioning thermostat that sticks partially closed causes engine operating temperatures to rise beyond normal ranges. Monitor your engine temperature gauge, because temperatures above 210 degrees Fahrenheit significantly reduce air conditioning cooling efficiency as your entire engine bay becomes superheated. This elevated temperature affects your condenser's ability to dissipate heat from refrigerant, essentially fighting against your air conditioning system's heat exchange process instead of supporting it. Clean your radiator and condenser fins simultaneously because dirty or clogged fins create airflow restrictions that reduce both engine cooling and air conditioning performance. Remove debris, leaves, and dirt that accumulate on fin surfaces because blocked heat exchange reduces cooling system efficiency and creates cascade effects that impact air conditioning operation. Replace your engine coolant and thermostat when air conditioning efficiency drops noticeably as engine temperatures exceed normal ranges. Low engine coolant levels or degraded coolant condition exacerbate cooling problems by reducing your cooling system's efficiency, creating problems that appear to be air conditioning related but actually stem from inadequate engine bay heat dissipation. Secret number 5 shows electrical problems that confuse mechanics but are actually common and cheap fixes for car AC hot air issues. Check electrical parts first because they break often and look exactly like expensive refrigerant problems. Test fuses and relays with a meter instead of just looking at them. Since electrical problems come and go, make sure your compressor clutch gets 12 volts when you turn on AC and listen for the clicking sound. Connect 12 volts straight to the compressor clutch coil to test if it works without all the control wires. Check pressure switches and sensors because broken ones stop your compressor even when refrigerant is fine. Pressure switches are like safety guards. They watch refrigerant pressure and tell the compressor it's safe to run or shut off now. High pressure switches prevent damage when pressure gets too high. Low pressure switches stop the compressor when refrigerant is too low. Temperature sensors tell the system how hot or cold things are getting. Replace corroded fuse holders and bad electrical connections that cause intermittent problems. Clean all connections, ensure good voltage, solid grounds, and clean signals through your AC control system instead of assuming mechanical failure. Secret number 4 reveals the evaporator freezing problem that creates a specific pattern. Your AC blows ice cold at first, then slowly gets warm as ice builds up on evaporator coils, blocking air and stopping heat transfer. This happens from low refrigerant, bad expansion valves, or broken temperature sensors. Spot evaporator freezing when your system works great initially but slowly loses cooling as ice forms on the coils. Turn off AC but keep the blower running to melt the ice, which brings back cold air temporarily, but this only fixes the symptom, not the real problem. Check your expansion valve or orifice tube that controls how much refrigerant flows into the evaporator. Think of these like faucets. They meter the right amount of refrigerant. When they break or get clogged, too much or too little refrigerant flows through, causing freezing. Replace broken evaporator temperature sensors that shut down your AC too early by reading wrong temperatures. Evacuate your system to perfect vacuum before adding new refrigerant to ensure proper operation and remove moisture that causes freezing. Understanding what constitutes normal air conditioning performance versus actual malfunction is critical because some variation in air temperature output is normal, particularly during initial startup or when environmental conditions change. Secret number 3 reveals vacuum system problems that cause your AC to randomly blow hot and cold air, as heat from your heater core accidentally mixes with cold air from your evaporator. Test your vacuum-operated actuators that control blend doors that mix hot and cold air, and mode doors that direct air to different vents. Check for vacuum leaks in lines, bad PCV valves, or brake booster problems that share vacuum with your heating and cooling controls. Think of vacuum like suction power that moves doors inside your dashboard. When vacuum pressure drops, spring-loaded doors automatically snap back to heating positions, blowing hot air even when you want cold. Vacuum actuators are like small vacuum motors that push and pull doors inside your dash using engine vacuum pressure. When vacuum is strong, they hold doors in AC position. When vacuum is weak or gone, springs pull doors back to heat position. Spot electric actuator problems by listening for weird sounds behind your dashboard, like clicking or grinding noises that mean actuator gears are broken. Replace bad actuators that have plastic gears that commonly break in certain cars, stopping doors from staying in the right position and causing sudden bursts of hot air when doors move incorrectly. Secret number 2 exposes AC system contamination that destroys everything and costs thousands in complete replacement when wrong repair attempts put harmful substances into your AC system. Never use stop leak products from auto stores because these are the most damaging contaminants that clog expansion valves, condenser tubes, and evaporator passages. Stop-a-leak products are liquid sealers that harden when they contact air and refrigerant, permanently clogging tiny passages. Moisture turns acidic inside AC systems and eats metal components from the inside. Remove contamination before it spreads, because stop leak may seal temporarily but causes worse damage than the original leak, requiring complete system flushing or replacement. Moisture contamination happens when your system opens to air during repairs without proper evacuation, and this moisture freezes at expansion valves or corrodes components. Flush your entire system when compressors fail internally because they release metal debris throughout your AC system. Complete cleaning prevents damage to replacement compressors. Check for metal particles from failing compressors that circulate and lodge in narrow passages, creating blockages that reduce cooling. Replace your receiver dryer whenever your AC system opens to atmosphere because these contain desiccant material that absorbs moisture. Saturated, they cannot protect your system from moisture corrosion. If your air conditioning blows hot air continuously for more than 5 minutes after cold start, this typically indicates genuine problems rather than normal operation. Secret number 1 exposes the heater core flow control problem that causes air conditioning systems to blow cold air initially, but warm air after your engine reaches operating temperature. Modern vehicles with blend door systems don't need heater control valves because hot coolant flows continuously through the heater core while the blend door controls air mixing. Older vehicles use coolant flow control valves that regulate hot coolant circulation through your heater core. Fix your flow control valve when it sticks open, because hot coolant continuously flows through your heater core during air conditioning operation, heating your heater core as your engine warms. Test your blend door operation, because faulty positioning allows hot air from your heater core to mix with cold air from your air conditioning evaporator. Adjust your valve linkage when your valve functions properly, but stretched cables or misaligned linkages prevent complete coolant flow shutoff during air conditioning operation. Replace your coolant flow valve when internal components fail or corrosion prevents proper sealing. That isolates your heater core from engine coolant circulation. Seek professional air conditioning service rather than DIY fixes that may cause long-term damage and higher repair costs. Use proper diagnostic equipment and follow manufacturer procedures instead of quick fixes that create more expensive problems than original failures. Understand that the root cause is often a leak, combined with improper refrigerant charge, compounded by potential compressor or belt issues that require systematic diagnosis. Now I'm going to reveal the 2 critical mistakes that 90% of vehicle owners make when dealing with air conditioning problems. These mistakes can destroy your entire cooling system and lead to engine damage that costs up to $7,000 to repair, so pay close attention. Costly mistake number 1 is throwing parts at the problem without proper diagnosis. Stop immediately replacing your compressor just because your AC blows hot air. Here's what actually happens. You walk into a shop, they see a non-working AC, and they sell you a $1,500 compressor replacement. But if your real problem is a $50 relay or a clogged expansion valve, you just wasted your money and still have hot air. Always demand proper diagnosis first. This means pressure testing, electrical testing, and leak detection before any expensive parts get replaced. If a shop won't diagnose properly and just wants to throw parts at your car, walk away. You'll save thousands by getting the right diagnosis the first time. Costly mistake number 2 is ignoring your engine cooling system when your AC stops working. Here's the connection most people miss. When your engine overheats, your car's computer automatically shuts off your AC compressor to protect the engine. So if your coolant is low or your thermostat is stuck, your AC will blow hot air, even though nothing's wrong with the AC system itself. Check your coolant level and engine temperature before spending a dime on AC repairs. If you ignore this connection, you could end up with a blown engine that costs $7,000 to replace. That makes AC problems look like pocket change. Apply these diagnostic secrets systematically, and your car's air conditioning will blow twice as cold while using less energy, and you'll prevent costly misdiagnoses that waste thousands on unnecessary repairs. You can also improve your cabin air quality dramatically by replacing cabin air filters and using contamination-free refrigerant that prevents bacteria growth. If you found these hidden car air conditioning secrets valuable and want to save thousands by understanding what professional mechanics actually do, hit that like button and subscribe for more money-saving automotive secrets that repair shops don't want you to know. I'll see you in the next video.